We continue with identifier. Identifier is the name of some element of a program that is defined by a programmer. Identifiers are the names of variables, methods, classes, packages, or interfaces. If you don't recognize some of the words, don't worry about it. It's going to be covered in a later tutorial. Identifiers can be anything except for Java keywords. And Java keywords is basically the same words that we already discussed. All this lowercase, package, public class, because they, as discussed earlier, these words have a very specific purpose. Also, the variable names, even though they are defined by a programmer, they should be given with some kind of purpose. For example, let's say we want to define number of hours. So you can definitely do something like, let's say integer x is equal to, let's say 5. So that means, like we said, that this x basically represents hours. Now, let's say you will show it to some other programmers from your team, or let's say in a couple of months from today, a couple of years, you're going to be looking at this code and you're going to ask yourself, what is x? So what you want to do is, instead of giving a very general variable name x, you actually can go ahead and give a specific name such as hours, number of hours. So for example, you can say int hours is equal to 5, and it's only one of the options. You could say number of hours. It's absolutely up to you. Also, Java programs might have thousands of lines of code, and it's very important to use identifier wisely. Also, the good use of identifiers will contribute to better understanding of your code, especially in the future. The code will be much more readable. Unlike Java keywords, identifiers can be lowercase and uppercase. So for example, you can see that the keyword always written in lowercase. But for example, for identifier, it could be like integer number of hours. So you can see that I can just play around with alternate between lowercase and uppercase letters. Also, capitalization will be useful, and it will help reading longer identifiers. And we tend to use something called camel case. So this time around, just for variety, I'll use double, which is a floating point data type. And let's say we have a camel case. The reason why we call it a camel case, just because it looks like a camel case. We have alternating lowercase and uppercase values. And for example, if you have something like that, then it's also camel case. But you can see that reading this is much difficult because there is no separation between the words. So camel case, it's very difficult to distinguish camel and case, as opposed to when you see something like this, you clearly see there are two separate words separated by lowercase and uppercase letters. Another example could be, you can say integer number, let's say num of books, number of books, toggle here, or you could say integer number of books. So you can see once again it's a huge difference as far as reading of the symbols of actual identifier go. So there are rules that you have to follow, and those rules are a must. So for using identifiers, so let's go ahead and use some of them. Let's use that. So there are three main criteria. I'm just going to create a multi-line comment. So like I said before, in NetBeans, it's a / to asterisk and space, and here we go. You can continue writing on any line you want. So first of all, the rule applies for first character. So let's say number one, first character must be, first of all, it could be lowercase or uppercase letter. So I'm going to say A through Z or capital A through Z. So that means all letters, lowercase and uppercase. As long as also we can start it with underscore or $sign. So this rules goes for the first character. Rule number two. After the first character, you can use, so let's say other characters. Well, I would say yeah, let's say other characters, meaning second and after. Again, it could use A through Z, so lowercase, capital A through Z, uppercase, digits 0 through 9, underscores, and again $sign. So you can see rules are pretty much identical as rule number one for the first character. The only difference is this time around you can use you could use digits. And notice that for first character, digits are not allowed. Also, let me go ahead and put not comma, I mean not dot but comma on the first rule, just not to get confused. Rule number three is uppercase and lowercase identifiers or characters within identifier are not the same. So this is very important note. So for example, if you have int hours, so let's actually declare this, or we actually had hours before, but it doesn't matter. Let's say int number, that's for the number, and let's say something like int number. So you can see that Java compiler does not complain, even though they look the same, they read the same, but capitalization makes it absolutely different things. So it's acceptable for you to come up with the same name but different case. I would not advise to have number and number within the same class, but so it might be a case that you could opt for it. Rule number four. There are no spaces. There must be no spaces whatsoever between between characters, between words. No spaces allowed. So, for example, if you say something like int number of hours, you won't be able to do that. It's going to complain. However, you have two options. You could be using underscore. For example, you could technically do something like that. No complaints there. Or you could just say put camel case, which also makes it absolutely fine. So let me give you a couple of examples for you to work on. So one of them is going to be apple. Next one is going to be top left. Next one is going to be top left, like this. import score-1 and 2D graph. You can pause this video, go ahead, provide your solution, and once you're ready, press play again, and we'll resume this. So here we go. We got, so let's say, solution to that quiz that we have. So we got all this. So let's find out. Apple. Is variable identifier Apple acceptable? The answer is yes, absolutely, because it's fine with the first rule, because first character starts with a letter, which is fine. Other characters also letters, which is fine. Upper lowercase, no problem there, and there are no spaces. So, for example, we could say something like int. I'm just going to be using integer for everything. That shouldn't make any difference. So if I say Apple, it's fine. There are no complaints about it. So next one is top left. When it's all together, it's one single word. Once again, it's absolutely fine. So we can just say top left because it's all characters, all letters. There are no numbers. The numbers it doesn't start with a leading number. No spaces, so we are absolutely good. So for the next one is top left. So notice that it's obviously going to complain. The reason being there is a space, so it doesn't follow up on the rule 4. So what we can do is we put underscore between top and left, and we resolve the issue. And again, it's just one of the options. You could just follow up on a second example, top left. You could write it together. It's a camel case, L is a capital, and it's easy to read. The next one is import. So obviously import, it's not okay. The reason being, notice that NetBeans actually converts this into the blue. Also notice that, well, actually we didn't cover this yet, but import, this is going to be a keyword. So you must not use keywords as mentioned also in the beginning, just because it's used to import different classes from other packages. So that's a definitely keyword with the specific meaning. To fix that again, you could use the capital one, and it fixes the problem. You could use any other word except for import. Import stuff, import apples, whatever you need to import, but make sure not to have it as a keyword. All lowercase, not acceptable. The next one is around is score-1, and once again, it's not okay because it has a dash, and none of those 4 rules listed allow us to have a dash. Number 2 rule doesn't allow us dash. So whether you eliminate it or put this underscore, it's up to you. And finally, 2D graph is not going to be okay. The reason being, it has a leading number. And once again, it's not acceptable. So you can go ahead and remove this 2 with 2D, something like that. Whatever fix you find, yeah, it's absolutely fine as long as you stick to those 4 main rules. All right, next. As far as identifiers go, it's a standard practice to differentiate class names and variable names. So once again, class name is something which goes next to the word class, like hello world. And for example, you got number of hours. So they are both programmer named identifiers, meaning the programmer gave its name randomly for some specific purpose. However, we do have a convention. So for variable names such as number of hours, the name must begin. Must meaning it's not a rule, but it's convention, so it's advisable. So your fellow programmers would be on the same page as you are. So you want to start it with lowercase letter. And if the variable name consists of multiple words, such as this one, now number of words, then you want to have each subsequent word to have it capitalized. So, for example, see we have number, num, of, O is capitalized, and hours, H is capitalized. And everybody can read and easily understand the camel case, as opposed to just having num of hours, all lowercase, or some other kind of variation. And as far as the class goes, by convention, again, the first letter of a class should be capitalized. That's why we have hello world. Also, you could do another example. You can say class person. Okay. So again, first letter it needs to be by convention capitalized. And if the class name consists of multiple words, then each subsequent word must be capitalized as well. That's why hello world capitalization goes in the first letter, and then its capitalization goes on a world for the second word. Okay, so enough about general rules for identifiers. Now let's move on to classifications of identifier. And as you will find out in a moment, that Java is a very, very strongly typed language. Variables can be classified by their data type. And this kind of data type, they can just store different kind of data. You can imagine there are various types of data in Java you have. We are mostly in this section we are going to focus on number types, but you can imagine there is a whole number, there is a fractional number. You might have a text stored, or you can have a character or bit, or byte, or whatever options are. We do have various data types to represent the data that we would like to store in memory. And choosing the right data type is important because it determines the amount of memory used by a variable, which we'll discuss in later sections. For example, there would be different data type for, you can imagine height of a building, let's say 10-story building, we could just pretty much measure in feet, and you can take distance from Earth to Sun, talking about huge number of miles. So this kind of values would definitely have an effect on its storage, onto amount of memory which is going to be used to keep this data. At this point, we will mainly focus on 6 primitive data types for numeric data. We'll mention also some example, and we'll talk about the size. So let me go ahead and just maybe I can just continue on. So just to keep those notes, so let's say, so here we're gonna say numeric data types. Okay, so first one, and by far one of the smallest primitive. Actually, it's not just numeric data types, but it's numeric primitive data types. And we'll talk about more about definitions and concept of what exactly primitive is. But for now, first one we got byte. Next one is short. Integer, just int. Long, float, and double. So here we go. Those are your 6 primitive numeric data types. As far as their size, you can represent it in byte, and you can also represent it in bits. Those are valid memory sizes, units of memory. And also we know that 1 byte is equal to 8 bits. So here, let me just make a note. 1 byte is equal to 8 bits. That's going to be important. All right. So as far as the size goes, well, let me actually make a note here on top so it would be clear. This is the data type. The next one is going to be size. And then we can just provide an example for each. This one example, so it would make more sense. Okay, so for the size, it's 1 byte, or you can say 1 bit. I mean, 1 byte is going to be 8 bits. So just because 1 times 8 is 8 bits. Okay. Example of this could be the number such as -50, +50. Should be all good. Next one is short. So for short, it's actually 2 bytes and 16 bits. So once you remember number of bits, once you remember byte, you would just should be able to calculate how many bits just by multiplying the number of bytes by 8 would always give you a number of bits. Short could be something like 2000. Next one is integer. This one is 4 bytes or 32 bits. And again, it could be negative or positive, 350, for example. Long. So the long is bigger than integer, double amount. It's 8 bytes, or we can say 64-bit. Okay, and example of this. So for example, you have to be careful when you say long. For example, you can technically say 10, but the problem is that compiler wouldn't consider this as a long one. That's why we have to use L appended to it. Long could be in lowercase, and long could be in uppercase. I would suggest you to have long in uppercase, just because L sometimes might get confused as 1. So for example, this one here, it might read like 101, even though it's 10L. Okay, so if you stick to uppercase, it's going to make it much more readable. So the next one is float. Float is 4 bytes. And again, it's 32-bit. Okay. The example could be some decimal which contains floating point to 234.5. And notice that to make this value to look like float, we have to add f. So in this case, we tell a compiler that yes, we do work with floats. And final one is a double. And again, it's 8 bytes. And 8 times 8 is 64-bit. And I would suggest you to remember those, or to really understand it well. It's very important because it actually deals with memory, and each program would have its own memory. Each server would have a memory where the program runs. So you have to try to save as much memory as possible, because it might get very expensive. And for double, you could just have a floating point number, positive or negative, 123.5. So that's about it. Just a couple of points here. So byte, short, int, long, all of them are integer types, integers. And float and double, they are floating point numbers, or sometimes called fractional values. So let's make a note. Those are integer values, and those are floating point. Okay, good. And also what's important, and we didn't really mention so far, is that each of primitive variables has its range. So for example, you cannot say, for example, for byte, for example, you cannot say that you're going to be using 26 I don't know, thousand, or like 26 million, take like a random number for byte type, because it's just not allowed. So we have to at least understand what is the range to avoid compilation problems as we move along. So here is the formula to calculate range in Java. So let's say range formula, range for data type. So that's going to be -2. So it is going to have some minimum value because it's range, so it should have a minimum value, and then it's going to have a maximum value. So -2 to the power of n-1. This is the lowest number, and then so you could say from this to, instead of equal sign, let me actually put column like that, and the maximum one is going to be positive number this time. So it's 2 to the power of n-1 as before. But then from this calculation, so you have to take it to the power first, and then you have to subtract 1. So this is the definition. So let's take a look at byte integer data type and take a look what is the range of it. So for byte type range, okay, so what we'll do is, and by the way, what I didn't note is that's very important, where n is the number is equal to number of bits. Okay, that's very important. Bits, same as this bit that we talked about before. So byte type range. So let's see. The n for byte, as you see, is going to be 8 bits. Okay. So now we have to just plug it in for the minimum, calculate it, and then for the maximum also calculate it. So it's going to be -2 to the 8-1. This is the minimum. So from this number to +2, n-1, which is 8-1, and once you get this calculation, you have to subtract 1 from this. So that would be equal to 8-1 is 7, and then we have -2 to the 7th power is going to be 128. You can take your calculator, you can check it myself before. So just because it's 7, it's an odd exponent, then -2 remains negative. Imagine if you have -2 to the power of 8, which is the even number, then you would get rid of this negative number. However, you have this negative number in front, so this is the minimum value you can use, and 2 to the 7th -1. So in this case, it's going to be 128 -1, which is going to be plus 127. And that's, there you go. This is the way you calculate range for primitive data type. You could go ahead and use this formula to calculate the rest. I'm not going to spend the time doing so. Maybe we'll do additional one in later tutorial, but this is a pretty basic calculation. Okay, so the next one, let's see. So just like we said before, Java is very strongly typed language, and you have to. It only allows you to store values of compatible data types in variables. Okay, so for example, let's go back to. Let me just get rid of those values for now. Okay, so let's say we already talked about float. Okay, so we can just get rid of this as well. Let's just keep some rules. Okay, so float was one of the it's a floating point type. So let's say float number is equal to 32.5, and you can see compiler complains, and if you approach it, let's see if it's going to say. It's going to say incompatible types, possible lossy conversion from double to float. So you can see that this is a double. See the one like the floating point, so it's actual double. But for float, we actually must have f in the end. So you can have it capital or non-capital. If you put f, that resolves the issue. Okay, and we'll talk about the losing data in a little bit. Floating literal points can also represent scientific notation. So for scientific notation, let's make a little note here as well. Scientific notation is represented by E notation. E notation. So this is something that you do in math or in science and chemistry or physics. For example, you have 1.2 times 10 to the n power. Okay, so that 10 base of 10 and any kind of exponent will be used with the E notation. Sometimes you can see this E in calculators. Some computers give you E, but let's take a look at some examples. So for example, you have 123.45. This is a decimal floating point value. Okay, and in this case, it would be equal to, now for scientific notation, you have to represent this value. For first number should be just 1 through 9 digit, and then you have to have a dot. So instead of 123.45, you actually have to move that dot to the left. So that dot should remain between first and the second non-zero numbers. So we're going to move this point 2 points to the left. So it's going to be 1.2345. But this time around, it should be times 10 to some kind of exponent. But notice that if we moved this point 2 places to the left, meaning we kind of divided by 100. So this time around, it should be power exponent of 2. So you moved it you moved it to the left over here. So over here you have to create positive 2. We'll talk about opposite ones in a little bit. Opposite kind of calculation. And for scientific notation in Java, you have to say 1, 2, 3, 4, 5 e to the power of 2, and that should do it. And same goes for when you, so 133.45, that's obviously greater than 0. There are numbers which are less than 0, and they would use negative they would use negative exponent over 10 by the base 10. So for example, we have something like 0.00012, and again, that's a decimal number. Okay, and again, now we have to move this dot to the right until you hit 2 non-zero digits. So it's going to be 1.2 times 10 to the, so if you move it, how many points here? 1, 2, 3, 4. So we move it 4 points. So exponent. So if you increase this number by 4, you have to decrease this number, I mean, quote unquote, decrease to the negative 4. Okay, and it would be 1.2 e to the negative 4. Okay, and let's just copy one of those values, and we can say over here, let's say double distance is equal to this scientific notation, 1.2 times 10 to the negative 4, and we can go ahead and just print it out to console and see what is it going to give us. So let's just run. And we get 1.2 times 10 to the negative 4, which is a valid scientific notation number. Now, the question arises, what is the primitive type? Why do we call it a primitive? So it is called the primitive data type because no object can be created from data type. So basically, that number or distance that we have, it cannot have anything, any kind of dot notations. It's just going to give us no suggestions because the distance is the primitive. It's so primitive that it doesn't have any additional methods or any additional objects which could be created from it. And variable can only hold a single value, and it wouldn't have any attributes as well. So it's as simple as this. The general format for the variable declaration is just a data type followed by variable name. So let's say it over here that it just declare. So let's say variable declaration. You have data type followed by variable name. Okay, and you obviously put semicolon. Okay. Also, Java allows you to have you can declare multiple variables as long as they do have the same type. So, for example, you could say multiple variable declaration, but it must be the same type. So you could do something like, oops, capitalization here, declaration. Okay, so same data type for all. It could be variable name 1 and variable name 2 and so on. And there is a quick example about this for this. So we have, let's say over here, we got double salary. That's fine. You can have integer height. That's fine as well. You can have double distance. That's fine. Oh, distance has been already declared. Okay, so let's say let's say width. Okay, and notice this: if you can, like mentioned before, if you can have multiple declaration as long as you have the same type. So you could say something like double. So we have double salary and double height. I mean, double salary and width. So let me just comment them out. So compiler wouldn't complain. So let's say double salary, comma, width. See, it works. However, if you want to do something like double salary, integer, width, it doesn't work because this only allows you to have multiple variable declaration as long as you have the same data type. Okay, so enough about numbers. The following one is the next data type, because it's not just numbers we have. We can also have data type such as a Boolean, something called true and false. So let's make edit to the list here. So let's say Boolean data type. and in this case it's it can only have, so we actually refer to it as a bool, B-O-L, and it's going to represent, it's only one bit of information. It's a very tiny piece of information, and example of it is just true and false. There is nothing else, just in true and false. So just to give us an example, just for example, we have, actually I apologize, not Boolean, I meant Boolean like this. So we have Boolean, bool is equal to true, okay? Or you can say Boolean flag is equal to false, okay? And you can just go ahead and print them out. So let's print them to output. So one is going to be bool, and the second one is going to be flag. Let's run. So for the first one, we should get true, and for the second one, we got false. So that's exactly the way they are going to be represented. The final primitive data type that we'll talk about is the character data type, or char or char, allows creating a variable holding just a single character. Character literals are going to be enclosed in single quotation marks. And let's make a note here. It's character data type, and we got so like this. And for the size, it's going to be 2 byte, or just 2 times 8, 16 bits. And example of this is just going to be one character, for example, A or B, and so on and so forth. You can imagine could be just dash, which is also just a character. Also, so let's give it an example. So let's say character char letter is equal to A, and this is actually very important. Let's see if we are going to print this out. Let's take a look what it's going to printing. So let's say we're just going to print it to console, this letter, and let's print it. Oops, let's try again. There you go. Sorry about that. So now we got A just being printed out. So just a couple of things to notice here. Character literals are enclosed in single quotations. One of the next topics is going to be strings, which is multiple characters. Instead of just one, it will be more like ABC, multiple ones. The strings are going to be enclosed in double quotes. However, the characters are enclosed in single quotes. Each character in Java is going to be represented by number. So even though you see A on the screen, but behind the scenes, it's actually the number. So for example, each character is assigned a unique number. Unicode, that's the way we call it, is used by Java for unique character codes. The numeric code is stored when the character is stored in memory. So for example, when you do say character letter like this, it's actually restoring actual Unicode value. So the A that you see on the screen, it actually means number 65. And if you say, for example, B, it should be incremented by 1, so that should be 66. Let's give it an example. So let's say character letter is equal to 65. And let's print this out. And we got A, because you can see that character, which has code of 65, gives us A symbol. 66, B, and so on and so forth. You can imagine Z, you can just do the math. And that's about it for the basic data types. Now let's talk about assignment statement. So an assignment statement is putting a value into a variable, and an assignment operator is the equal sign. So here we assign 66 code to the variable character letter. To assign a variable to a value to a variable, the variable name receiving the assignment must be on the left side of operator. So this letter will be receiving an assignment, and assigned value must be on the right side. Let's try another example. We got integer length is equal, or let's say length, let's keep it separately, so we are declaring it. That's a declaration, declare, and we can assign 20 to the length. So this is actually assignment. Now we can compare, we can declare and assign in one single statement. So we could say something like this: int length. Well, we actually used it. So let's say int width is equal to let's say 25. And you can see that this is something called initialization. So majority of times, we'll talk about exceptions later on, but the values should be initialized, declared and assigned before it could be used. So let's go ahead and save this for the future. Okay, just a moment here. Okay, final one. All right, now also Java allows us to declare variables and initialize others just in one statement. So we, for example, we do have something like this. We have integer num1 is equal to 89, num2, as long as they are the same types. And this is going to be num4, just like that. So this is allowed because all of them are integer types. As long as they're the same data types, we shouldn't have any problems with this. But you have to be very careful so not to get confused. Num1 is initialized to 89, declared and initialized. Num2 is not initialized. It's only declared. It doesn't have the equal sign. The 10 that you have in front has nothing to do with num2. Num2 is just declared. Num3 is initialized to 10, and num4 uninitialized. It has been declared, but it hasn't been assigned. And note that all variables within the method must be declared and initialized before they can be used. And variables can only hold one variable at a time. And also we got, let's talk about operators. Java provides many arithmetic operators. There are many common ones you heard before. For example, plus, minus, divide, things like that. We'll talk about those in a moment. But mainly there are three types. So let's see. Let's put here an additional rule. So we got arithmetic operators, and there are mostly three types. It's unary, binary, and ternary. Unary, binary, ternary. So unary operator type requires only one operand. So those are they all depend on number of operands. And operands, those are the values which surround arithmetic operator. 2 plus 2, 2 and 2 would be operands. So when it's a unary operator, it must have just one operand, and binary would have 2 operands, and ternary would have 3 operands. One of the examples of unary operators is a negative in front of a number. So for example, if you have, let's say, num5 is equal to -6, that's your example of unary operator, because it only has one operand with the negative in front, which we actually refer to as negation operator. Now, binary operators are, majority of binary operators, you know, so let's say binary operators are as follows. It's the plus, it's the minus, it's multiplication, division, and modulus. All operators work as you would expect it in math. The only one operator you might be unfamiliar with is the modulus, the one over here in the end. The modulus operator returns the remainder of division of 2 integers. So for example, if you have, let's say, this one returns remainder of operation. So let's give it an example. So let's say integer remainder is equal to 17 modulus 3. So even though it looks like percent sign, it's really not. It's actual modulus. It returns us remainder. So 17 divided by 3, typically speaking, let me just do this as a comment. 17 by 3, it's like 15 divided by 3 is 5, but 17 minus 15, so that's approximately 5, but 17 minus 15 is equal to 2. So this is our remainder. So let's print this out and let's just confirm. And print to screen, and we got the 2. So it actually returns the remainder, not just calculation. So now a couple of other things. Integer division. So when you do declare integer and you when you use integer as operand and you don't have decimal point, it's actually going to drop all the fractional part. So the fractional part of the result is going to get truncated. So let's give an example. So let's say we have double, which you kind of know it's a floating type, the one we mentioned before. So let's say double number is equal to 5 divided by 2. So you would say, well, it's 2.5. But it's really not, because it's going to get truncated. And the reason being is because none of those operands are using, so you can see it actually gives us 2.0, not 2.5. So it actually gets rid of, it gives us the decimal, but it gets rid of the decimal point. So if you use at least one of them with a decimal point, with a floating point, then it gives us correctly 2.5. Okay, so just be careful, it's very important. Obviously, we do have mathematical expressions, can be built with several operators. So we only saw one kind of binary type, but you can have plus and minus and multiplication, divisions, which probably reminds you of a high school PEMDAS. So parentheses, exponents, and all of those operators. A mathematical expression can be built with several operators. Operator precedence have to be considered. the expression gets evaluated obviously from left to right. And when two operators surround the operand, the operator with higher precedence gets evaluated first. So let's say we have a precedence. Let's actually make a note here. So precedence, and we can have highest. Let's say highest. Let's say highest precedence, and then we have precedence low. Yeah, it doesn't matter. I was thinking about the ways to give it as easy as possible, but I think it should be all right. So for the high, we have unary negation, just like a negative, making positive number negative. So unary negation, and also we have multiplication and division. Okay, and for the low precedence, it's plus and minus. Those are common ones. They are very decent subtraction, like in PEMDAS. They are A and S. They are lowest priority. So let me give you an example here. So let's say double number is equal to 6 minus 3. And let's say times 2 plus 7 minus 1. Okay, so just do the math. You can pause this video for a moment. And here's the answer. We have, so first of all, there is a multiplication we can spot. So 3 times 3 is going to be 6. 6 minus 6 is going to be 0. 0 plus 7 is 7. 7 minus 1 gives us answer of 6. And let's just print it to the screen just to confirm. And that's exactly what we get. And again, we get floating point just because we're using double. Also, PEMDAS contains parentheses. So parentheses are going to be grouping expression. So for example, let's say double number. So let's do some parentheses work here. So we're going to say something like 6 minus 3 multiplied by 2 plus 7 divided by 3. So again, pause the video, do the math. But so now welcome back. We have 6 minus 3 is 3. 2 plus 7 is 9. So 3 times 9 is 27. 27 divided by 3 is 9. So that should give us 9. And let's check the work. Okay, and it is 9. Okay, so that's very simple methods, but try be very careful as possible, because we usually do mistakes on easy concepts as opposed to more difficult ones. At least I do. Sure, I'm not alone on this one. Okay. Also, Java has a lot of built-in operators, built-in kind of data. For example, like your calculator who have like an exponent. For example, if you wanna do let's say exponent to 2 to the 6, let's say, or whatever, 25 to 100. You don't want to do it by just manually, or just do like 25 times 25 times 25. But you actually, Java has a class. It has an API class math with many numerical operation. I'm going to demonstrate 2 methods and 1 constant. One is going to be for power, and this is going to be, and the second one is going to be for square root. So for power, the method obviously has to take 2 arguments, one for the base and one for the exponent. So let's give it an example. So let's say double number. It's going to be math. Now look. So math, and we are going to be using power method. So you can see it actually keeps on suggesting us it's pow. And again, it's C, it's double A, double B. So let's say we want to take 4 to the second power. So let's say 4.0 times to the 0. So that should be 16. Let's just do a quick check. And it is 16. It works as expected. This next one, for example, you have a square root. So let's say, let's do a little adjustment here, so not to rewrite this whole thing. So square root is the next. The square root would take just one double value and return the square root of that argument. So for example, 9.0 is an example. And let's run it. And as it was expected, it gives us 3. Also, the math class has some predefined values, such as pi, which is refers to the circle. We all know it's 3.14 and unlimited number afterwards. And pi, which is used for area of circle, for example. So we have a formula of area. Area of circle is pi radius square. So let's say the radius, let's say radius is equal to 3, okay, and we have an area which is equal to pi. So once again, we're going to be using math pi value, and you can see it's a constant provided by the class Java library, and there's going to be times radius. So you could do math power. So let me give you 2 examples. So one is going to be radius times radius. So it's going to be radius times radius. That's example 1. Also, let's just print this one. So just give us area printout. And also we got, let's do another kind of scenario when you have math pi. Just to show you variety. They all do the same kind of stuff. But math pi multiplied by math pow, and again it takes integer to it takes base double value and exponent. So it's radius to the second power, so 2. Let's just do a quick math. So let's say this is going to be a calculation. Just do a little bit different here. And this is going to be the method B, second method. Let's run. And you can see it gives us identical values. So once you get used to it, it really becomes very, very basic stuff. Also, we do encounter combined assignment operators. So something like assignment operator equals sign in combination to another operators. So combine assignment operator combines the assignment operator with the arithmetic operator. The same variable appears on both sides of the equal sign. And for convenience, Java provides us with this kind of method. So let me give you an example. So let's say, let me just get rid of this stuff. So let's say int hours is equal to 3. And let's say we want to use, and we need to reinitialize hours. And let's say hours is equal to hours, initial number of hours plus, let's say 4. So definitely you expect 7B answer. So this hours is going to get overwritten as opposed to it was in the beginning. So hours is equal to, and we assign it hours from the previous line, which is the 3 plus 4, should give us a total of 7. And let's run. And there you go, it got 7. And Java provides us with the combined assignment operator. So instead of doing something like this, you could do something like that. You could say hours. So you can, since it has hours twice, and since as a programmer who doesn't like repetitions, we just put plus equals 4. So basically all of this summary of a previous line. So it's actually equal to, so hours are equal to hours plus 4. So plus equal to 4. So this line and the line above, they are absolutely identical, and it still gives us 7. Same goes to operators as before, including modules. All right. The next one is conversion. Let's talk about conversion between primitive data types, because it's actually a very, very important topic. Let me go ahead and remove this. All right. So conversion between primitive data types happens when you need to convert, for example, integer to the double, or double to the integer, or to some other value. So before storing a variable, you have to make sure that the value's data type matches the variable's data type. So for example, Java would complain when a double value is stored into integer, because as you saw before, a double is 8 bytes, and if the integer is only 4 bytes. So obviously you don't want to store 8 byte into the 4 byte unit. We'll talk about it. I'll show you an example in a little bit. If double value is stored into integer, then there would be possible data loss. But for example, if you have a short and integer, and let's say you want to store short into integer, just according to this concept here, that shouldn't be a problem, because short is just 2 bytes and integer is 4 bytes. So it's fine, because 2 easily fits into the 4. So in this case, there is no data loss. However, Java allows us a way to store short value into the integer, which we'll talk about in a moment. So let's talk about the ranking of primitive data types from lowest to highest rank, because all those data types that we talked previously, actually let's make a note here next to the data types over here. So let's say lowest rank to highest rank. And those go as follows. Starting with byte, then short, then int, then long, float, and double. So this is their ranking, where double is the highest ranking type and byte is the lowest ranking type. And conversion could be 2 types. One is widening conversion, and the second one is the narrowing conversion. So let's talk about widening. So the widening is an automatic conversion. There is no data loss. It allows us to store lower ranked value to the higher ranked value. So I'll just take this rule a little bit higher, so that would be easier to see. Okay, so let's see. Let's say we want to store integer into the double. So let's say int y, integer y is equal to 10. And let's say we have a double x. And let's see if we can store integer into it, y. Notice that compiler doesn't complain because it's widening. It's assignment of a lower ranking value to the higher one. No complaints. However, we also have a narrowing conversion. So narrowing conversion, as you can imagine, it actually does exactly the opposite. It converts higher ranked value into the lower ranked value. This conversion is not automatic, and there is definitely possible loss of data. So for example, this time around we have double y is equal to 10. And let's say we want to assign 10 to the integer. 10, which is double value, to the integer, which is integer x. And notice what's going to happen. First of all, let me just comment these 2 lines above. There you go. So notice what it says. Incompatible types possibly lost a conversion from double to int. So that doesn't work, because notice that double, again, it's 8 bytes, and integer is only 4. So you're trying to fit 8 bytes of a memory into the 4 bytes into the memory. So that's a problem. However, even though it's not automatic, Java allows us to use a cast operator. Cast operator allows a manual conversion of the value, even for an Erwin conversion. Cast operators are unary operators because they only involve one operator. So for example, this y is going to be casted to the integer, and it's only one operator is being used. That's why when we use this, so even though y is double, but we are going to overwrite it and make it integer, and now it doesn't complain anymore. So basically what happens is it appears as a data type name enclosed in parentheses preceding the converted value, which is in this case it's y. It doesn't change the context of the variable y, but it returns the value stored in the variable converted to the specified data type. So you can see that it's actually truncates, well, not exactly truncates, but it actually casting. It's casting the double into the integer. Let's try another example. We have double number. Let's say double num is equal to 72.567. And let's assign this to integer. So integer x is num, and again it's complaining about talking about data, lossy data, again as before. So what we'll do is we'll put integer unary operator in front, and let me actually take a look here. Oh, just because it has already been declared. Okay, let's say double num. Let me see. Oh, because x is being sorry. Yeah, so we got this problem. Okay, here we go. Yeah, so obviously if you have a number, then you cast it with an integer, and you do get integer. So the operator returns 72 instead of 72.567. So you can see the decimal part of it gets truncated. The operator returns 72 and assigns it to num. And one more rule that we have, a special rule when it comes to integer, bytes, byte, and short. Byte and short. So when anytime you are trying to do an operation with integer, byte, and short, the byte or short data types temporarily get converted to integer value. The result of an arithmetic operation using only a mixture of byte, short, or integer will always be integer. So for example, when you have, let's do an example, we got short b is equal to 3, and I'm gonna do comma, I'm gonna assign another variable c is equal to 4, something like that. It's valid because b and c belong to the short. And what you want to do is I'm going to add b and c and assign it to the A. So A is equal to B plus C. And obviously I need to have data type in front. And like we mentioned before, anytime you work with a shorter byte, they get changed, temporarily converted to the integer. So we can easily say integer like so. And it's fine because they get, it's a widening conversion. It's short, easily assigned to the integer. And let's print this out. And there you go, we got 7.